When a developer builds a mobile application, the initial focus is on proving the concept, but the code required to validate an idea rarely sustains it at scale. Experimental prototypes frequently fracture under the weight of enterprise requirements. Consider the native Android application JBL SoundProof. It was originally built as a focused experimental utility for adaptive noise masking. Transitioning that utility into a secure, enterprise-grade platform requires entirely gutting the original foundation rather than applying surface-level patches. That architectural overhaul is complete with the release of version 2.0. This upgrade replaces a flat prototype with a multi-layered architecture. The system is divided into 3 distinct vertical layers: an underlying data layer, a central command UI layer, and an independent processing core. Pillar 1 secures the base with robust cryptographic security protocols. Pillar 2 establishes dynamic user management through a centralized UI hub. Pillar 3 implements fragment-based decoupling to isolate audio logic from the interface rendering. These 3 engineering pillars establish the necessary framework for a resilient enterprise tool. Early prototypes frequently rely on hard-coded access logic. This creates a static entry point that compromises the security of the entire system. Version 2.0 addresses this by migrating to dynamic local persistence via a native SQLite relational database. To secure the database, the system uses cryptographic hashing. A password passes through a SHA-256 node, converting into a randomized hash. This hash is the only data stored in the SQLite database. Future logins are hashed and compared against this stored value. Because the system never retains plain-text credentials, zero-trust local persistence neutralizes the primary vector for unauthorized access. Shifting focus to the interface, early builds often suffer from friction caused by disjointed screen navigation. Version 2.0 moves to a centralized dashboard. This acts as a unified command hub, using real-time status indicators and a navigation drawer for multitasking. A dedicated management console is now embedded within this interface. This console allows system administrators to dynamically provision credentials and control access to the isolation tools directly through the application. Gating these critical utilities behind administrative role-based access enables the software to securely function as a highly deployable organizational asset. By far, the most critical technical challenge for this entire application was maintaining absolute stability during continuous heavy audio processing. The original utility used a monolithic activity structure, where the interface and background logic share a single architectural block. Running continuous noise masking loops within the main UI thread monopolizes system memory. This mismanagement causes UI blocking, visual stuttering, and eventual application crashes. Tying background tasks to front-end rendering creates an inherent instability that limits the software's potential. The solution in version 2.0 is the migration to a fragment-based design. This design separates the UI layer into modular, lightweight fragments. We extract the heavy noise service logic from the UI stack entirely. These fragments operate independently of the audio processing cycle. Dedicated data pathways allow the UI to control audio without bearing its processing weight. Following this separation, main thread CPU usage drops significantly. Memory leaks caused by UI lifecycle events are eliminated. This guarantees continuous audio playback even when navigating menus. UI blocking is prevented, even under maximum processing load. Background audio state persistence is improved when the application is minimized. This decoupled structure makes future feature integrations safer to implement. Decoupling presentation logic from background processing provides the stability necessary for enterprise-level performance. By reassembling the secure database, the central UI hub, and the decoupled audio service, we can view the system as a whole. The database integration and optimized threading result in a lighter battery footprint and boosted efficiency. The fragment-based UI provides improved UX and more precise environmental control. Isolating the noise service ensures enhanced reliability and continuous background masking. The performance metrics of JBL SoundProof v2.0 result directly from this multi-layered integrated architecture. JBL SoundProof version 2.0 is a secure hardware companion platform. Its development required the elimination of hard-coded vulnerabilities in favor of local cryptography. It required the separation of UI structures from heavy background processes to enable actual scale. True enterprise scaling is not achieved by adding features to an old frame, but by having the discipline to rebuild the foundation.